In this first part of the mini project, you need to develop a sub-VI that can generate the attack, decay, sustain, and release portions of an envelope as specified according to the drawing. Let me illustrate a couple different techniques, and of course there's probably many others, but here's just a couple ideas to get you started. If we look under signal generation, we have this built-in sub-VI that generates a ramp pattern. Just get some quick help on that one. And I think what I'll do is look at the output of this device using a graph. And I'll just run this with its default values and see what we get. Generates a linear array from 0 to 1, and it turns out its default value for samples is 128. You can then wire some additional or some different values to specify the new value of the start point and the stop point. Now you can start to see how this could be useful for forming the beginnings of our ADSR pattern. Here we see it's now varying from -40 to 0. So that would correspond to the decibel version of our attack portion of the envelope. Now let's try using the same concept to generate the decay portion. So I'll have this start at, or I'll have it start at 0 and end at -10, just as a -10 dB, just as a specific example of that. What I need to do then is concatenate these two arrays together. So select the build waveform and then select, and you have to do that before you establish your wiring, by the way. You have to select the concatenate inputs option for that. Okay, so it looks like we're starting to make some good progress there. In terms of establishing the appropriate number of samples, let's just find out how many samples we're actually generating. Let's scoot that over there. And again, with the default setting, each of these generates 128 samples, so we see 256 altogether. You know, again, that's just confirming what I had said earlier about 128 samples being the default. Also, I'll just make you aware of certain things that could become important here. There's an additional control that can be used to exclude the endpoint, and that could be important if you're trying to concatenate multiple ramp patterns together. And you can set that as a Boolean constant to the node that's on the top of the ramp generator. Well, let me turn to another possibility here. This is under the interpolation subpalette of the mathematics library. And this is the built-in sub-VI called Interpolate 1D. The general idea here is that you establish some essentially base points where you say these are some XY pairs that defines the critical points of the waveform, and then it will interpolate between those points. I'm going to establish two array constants for this demonstration. So say at time 0, time, let's stretch this out a little bit bigger so we can see something besides 0. Sometimes it's a little bit tricky to try to get a handle on where the box endpoint is. So what I'm doing here is specifying, say, 3 values for my horizontal axis at 0, 0.2, and 0.5. So at time 0, I want the value to be minus 40. At time 0.2, I want it to be 0. And at time 0.5, I want it to be minus 10. So this would be like the first 2 segments of our envelope. So I'm going to borrow my same waveform graph indicator. Now if you look carefully at this, we see that time isn't really matching 0 to 0.5. And also, it would be a good idea to really establish how many points we in fact have. And so at this point I'm plotting the actual data points now. So we don't have very many points being established. The way that you go about getting more points to be interpolated is to apply a value or an array of values to that xi input, and that establishes the points that we need to actually do the interpolation. So let me apply a little bit more dense array and see what we get. Well, this is not quite what I might be expecting here. Let's see if we can figure out what's happening. I was kind of expecting we'd see like the attack and the decay part. Actually, if you look carefully at this, we see that the start and end points make sense. Samples, well, that's defaulting to 128. Actually, the trouble is up here. When I was wiring my constants, I accidentally got these turned around. So my top array constant is the x values, and the bottom one is the y values. Hey, there we go. That looks a lot better. And again, we can also see now that we're generating a whole bunch of points in between those critical points that had been established by the array constants. I'll just try adding one more there. So hopefully those 2 ideas will give you some good hints about how to proceed.